Okay, hello, welcome to Geometry Unit 1, problem number 114. Got some more algebra stuff going on here, solve each equation for x if possible. And so we're going to cross multiply here, so we'll write it out. 4 times negative 5 equals 11 times 3x minus 1. Now, one thing to note on ones like this where there's two fractions that equal to each other, you're going to cross multiply. One of them is negative. Assign that negative to one of those two values, either the numerator or the denominator, but not both. So I chose to make the negative go along with the 5, make that negative 5. Notice the 11 is positive. So one or the other, just not both. So when we distribute this here, we get negative 20 equals 33x minus 11. So let's add 11 to both sides. Right at an angle here. Negative 20 plus 11 is negative 9. So negative 9 equals 33x. Dividing both sides by 33, we get x to equal negative 9 33rds. Each of those are multiples of 3. So negative 3 11ths would be the best answer. In part B here, we have binomial times binomial. Most of you have probably learned this by doing the box and diamond method or the FOIL method. I learned by just distributing the factors into the other polynomial. And so I am going to go through how each one is distributed here. So 5 times 2x is 10x. Then we also have 5 times positive 3, which is 15. Negative x times 2x is negative 2x squared, and negative x times 3 is minus 3x. If you prefer the box method, you'll notice that the values in the box are the same as these 4 values here. This is the extremely long and difficult way of doing this problem. You get a quadratic, and then you try and solve that quadratic by using the quadratic formula. Okay, fortunately for us, this quadratic has already been factored into these two polynomials. Okay, so we can take a shortcut. This is good for us that it's factored into these polynomials, because that means we can set each of these polynomials equal to 0. Now that will allow us to find the value of x. So usually we're given something messy like this, and we have to turn it back into the factored form. Okay, this is what we want, the factored form. So 5 minus x, set it equal to 0. 2x plus 3, set it equal to 0. So 5 minus x equals 0, that means negative x equals negative 5, which means x equals 5. There's one of our solutions for that problem. The other one, I'm going to subtract 3 from both sides. 2x equals negative 3, divide both sides by 2, x equals negative 3 halves is our other solution. So there's two answers to part B. You got to have both of them. X equals 5, or x could equal negative 3 halves. Okay, part C. Looks like we're going to have to distribute here and combine some like terms. So 6 minus 10x plus 15 equals 4x plus 7. Negative 10x, I'm just combining like terms here. 6 plus 15 is 21. Okay, let's add 10x to this side. 21 equals 14x plus 7. Let's subtract 7 from this side, and we get 14 equals 14x, which works out nice to give us x equals 1. Okay, part D. Okay, a couple ways we could do this. I am going to give you the process that will get rid of fractions. I know a lot of you see this and you see 3/4 x and you freak out because you don't like fractions. You're like, how am I supposed to subtract 3/4 x to the other side? Some of it is number sense and mental math, knowing that 4x minus 3/4 x is just 3 1/4 x, right? And then being able to write that as a mixed fraction or reduced fraction. But if you really don't like fractions, the way to get rid of them is to multiply everything by whatever is in the denominator, in this case 4. So we're going to multiply everything in here by 4, not just a fraction, we're going to play everything. So 3x over 4 times 4 is just 3x. 2 times 4 is 8. 4x times 4 is 16x. And negative 1 times 4 is negative 4. Now it's a plain old linear equation here, no fractions, no nothing. 16x minus 3x is 13x. Let's add a 4 to both sides. So 12 equals 13x. Divide both sides by 13. X equals 12/13, which is reduced as much as possible. So that is our answer.